I'll start with the introductions. I'm Michael Smith. I'm the Vice Chair of the Electrical and Electronics Division, and I'd like to welcome you to this evening's event, hosted by the Electronic and Electrical Division in collaboration with the Young Engineers Society, where Jeffrey Roe will discuss DIY low-cost air quality monitoring and the community that it drives. The quality of air all around us is important to everyone. The widespread research to highlight its overall impact on our daily health and life expectancy. Currently, most government monitoring is done with a very limited number of sensors across the whole of Ireland. Often, we are relying on data modelling to make the best guess of current levels. The processes can miss out on local pollution sources or seasonal data. This webinar will look to cover the approach which the citizens and science community are taking to tackle these issues. We will go into the details of how low-cost air quality monitoring kits are being made by non-technical people. The greater the learning which people gain from building these Internet of Things devices, the greater the understanding of the atmospheric particulate matter levels will be. In this webinar, we'll also touch on the difference these units provide compared to accurate collaborative professional equipment. So just a little bit about the speaker. First of all, Jeffrey Roe is working as a software and hardware engineer, currently employed by Kellic, an Irish-owned software and services SME. For the last number of years, Jeffrey has gained a wealth of experience in building public transport systems, from bike share schemes, parking and port traffic access management systems. In his spare time, he likes to make crazy projects like bubble machines, bone conduction, Internet of Things projects, and anything with LEDs in it. A big fan of getting people making. He co-runs Dublin Maker, an annual Maker Showcase Festival, and Dublin's Hackerspace Talk. Never afraid to put his hand up for volunteering in Engineers Ireland, he currently serves as a council and executive board on the council and executive board, as well as the Electrical and Electronics Division Committee. Jeffrey has a bachelor's degree in digital media engineering from Dublin City University. And without further ado, I'll hand you over to Jeffrey.
Well, welcome everybody. Thanks for that introduction. Just a few reminders that you can pop any questions you have in the Q&A feature on Zoom, and at the end we'll try and get to as many as we can and get you more interest in the topic. I guess to start off, to give you a bit more about my background and to add a bit of colour to what Michael has already said. Yeah, I have an electronic degree from DCU. I started off working in assistive technologies. I did a stint in Google, but for the last number of years, I've been mainly in the SME sector. Starting off with kind of parking, looking at system integrations for cameras, barriers, that sort of thing, building apps so people can pay for the parking on the street. I then moved into kind of lower level coding for public bike schemes in Cork, Galway and Limerick, where I was dealing with RFID readers, dealing with LEDs, buttons, that sort of interaction, kind of low-level coding. Then I used a bit of Linux skills to harden kiosks that I use on the street, make them more secure and extended lifetime, and have them run a bit. And then in recent years, I've kind of moved on to transportation systems around ports. So the image on the right there is a site visit I did there early in the middle of 2019 out to Senegal, looking at how to build transportation and access systems for the port of Dakar. So how trucks can come in and out, booking, making sure the correct tariff is paid, making sure that bit of critical infrastructure runs as smoothly as possible and gets as much cargo through as possible. Then to give you a bit of outside of work and what I do, everything else, yeah, I'm really into doing lots of things with hardware, because majority the job does a lot of software stuff. So the image on the left, these are some projects I've made over the last few weeks and just post-lockdown. So we have a weather station there. So from the comfort of my living room, I can find out what temperature it is outside, what the wind speed is, what the rainfall is, all those sorts of measurements that I wouldn't know what to do with, and then they all get uploaded to the cloud so you can access them everywhere. On the bottom is some LED strips I have, addressable LEDs, so they went into the sign behind me that's flashing. I'm also interested in kind of not just building new things, repairing old things. So there's my keyboard. taken to bits with all the keys out just before I put it into the dishwasher, but I'm often fixing radios and bits of electronics and that sort of stuff and trying to get a new lease of life. And then because we're not doing the talk in person like we normally do, and the internet is made of cats, there's a photo of the cat outside looking grumpy a bit in the rain. But yeah, these are all the kinds of things I'm interested in. So let's jump on to air pollution, of what tonight's all about. So this image was made by the UK government for Clear Air Day about 2 years ago. It shows all the kind of common sources of air pollution. So we have the ones that we all are familiar with. So factories, transportation. Some ones that you mightn't be aware of, which would be burning kind of wood and coal in stoves and open fires. They have a big, big impact on our air pollution. And then we have stuff like from farming, manufacturing, and then construction sites. You have dust and all those sorts of things kind of impact the air pollution around us and our health. So who's meant to be looking after this? What's this all around, and why? And we're going to talk about the ordinary citizen tonight. So the EPA are the agency that look after this on behalf of the government. They look after our environment of our island. They monitor changes, trends, look for the warning sign of neglecting our environment. They have like primary responsibility for issuing environmental licensing, enforcing environmental law, monitoring the data to make sure we've hit our EU targets that we've agreed to on our emissions and our air quality. They're primarily involved in education and guiding the public to understand all the issues and impacts on the environment. They look at doing they sponsor a lot of primary research and looking at the data that they monitor and trends and how we can live in the built environment and the environment on the islands. So they're decentralized from Dublin. They're based in Wexford, and they have a number of different kind of regional offices around the country. So if we look at just air quality, these are all the things that the EPA monitor. Now, I could do a whole talk on going into each one, the impacts each one has on their different healths, cancer rates, lung quality, lung capacity, all those sorts of things. But it's really beyond the kind of scope of tonight's talk. They're very different. They're very different pollutants in the air. Some of them, all of them are listed here. We have lead, we have mercury. Some of these are released from industry. Some of them are typically found due to transportation. So there's a lot of different things, a lot of different pollutants that the EPA monitor in the air. So how do they go about this? They use monitoring stations. So I took these photos from the EPA website. So on the left here, we have their mobile unit. So they bring that out and do temporary monitoring in a particular location for a number of months. And on the right here is some shots from Dublin City Centre monitoring station. So the last slide had a list of lots of different things that the EPA monitor. What we need to understand is most of the EPA sites don't monitor everything. The units would be too big. The machinery would be too expensive. So on some sites, they monitor a small amount. So to the photograph on the right, we have a much smaller unit that's just measuring the PM levels. And that's mainly looking at traffic and kind of home heating pollution. And then we have other sites that would be, say, near Dublin Incinerator, where we'd have a much greater suite of sensors because we want to capture environmental data of like the large incinerator or stuff like that. So each sites have different niches, and not all sites will have the full suite of sensors. So earlier this year, 301 days ago, it looks like the EPA launched this great website called airquality.ie. It makes it really easy for the citizen or anyone to actually get the EPA data in real time and have a look of how it's impacting their daily life. So previously you would have to, the data was open, but it would be in, say, CSV files, or you'd have to download a report. But this new website from the EPA, it's great. has all their sensors listed. You can click in it, see what the values are. The values are explained as which values are good, which are bad. So the average citizen can grasp what is good for their health. Is the air quality good? They can understand that maybe they'll recognize that, hey, there isn't a sensor within 50 kilometers of me. What is that? They can start asking questions. So recently at the EPA conference, they made a great announcement that they're continuing to roll out more and more sensors. So in early next year, we'll see a lot more sensors added, and they should make it over the 100 mark. Another thing to note on this website is we have the EPA sensor data, but we also have what they call network stations. So these are stations not run by the EPA, but run by your local county councils, city councils, and they also feed into it. So that's why on the map we have 84 stations listed, where the EPA wouldn't run that many stations themselves. So if we take a step back and zoom out for a moment and look at it at an EU level, this is a map from the European agency who's meant to keep an eye on all our member states about their air quality. So this is an image from their website where you can view the real-time data from all the member states. I guess I really put this here is for you to look at the image and look at the density of sensors some EU countries have. So you can see Germany, they're kind of in the middle. They've a lot more density of air quality monitoring than we have there on the map. So I guess it's to show that it's great to see the EPA are launching more and more air monitoring sensors, but clearly we don't have the density yet compared to some of our fellow EU members. So jumping back to a more personal story, how I got involved. I didn't study environmental engineering. Before March 2019, I wasn't that much involved in air quality aspects. I didn't follow it that much. It kind of all started by a tweet, this lady from Dublin who was lamenting the fact that Air Aberdeen, so this citizens group in Scotland, were coming together and doing such good work where they're getting ordinary citizens using the local makerspace to help them build and deploy all these sensors in their community. And she was lamenting the fact that that she didn't know anybody in Dublin doing it. So over the last number of years, I've been going to a lot of kind of electronics conferences, maker conferences, those sorts of things. And I had got to know a lot of the people who lived in Aberdeen who worked at the local makerspace. And then they suggested to her, why don't you contact TOG, so the makerspace that I'm involved with, and maybe they can help you build a sensor. So this was a great kicking point. It was a project from the website. Oh, great, this is a nice IoT device, some coding, some electronics. It really sounded like something that I'd love to get involved with. So I went on the internet, ordered all the parts that they suggested. I had to order them from lots of different suppliers. There was no kind of uniform place to buy them. I got all the parts for the kit. You can see, so I bought for 2 people, myself and having spares to help that lady build hers. And then you can see in the photo, it's all kind of jammed together. In my true fashion, I just threw a load of hot glue in there, stuck it in, and see if the whole thing would work. So here's a picture of it stuck to the outside of my house, and a nice pipe painted to get rid of the kind of orange look. You can see that there's a USB cable coming out of the side, so that gives it power. And then there's a tiny tube that comes along the inside of the pipe that allows the fresh air to come in. And then it connects over Wi-Fi, and then the data is viewable on the internet, and we can see it. So it was pretty much a fairly involved process. I had to download the source code, compile it, load it onto the microcontroller, install the driver, order the parts from various different places. So I did kind of understand why this lady felt it was hard to make one herself. And really the kind of lots of barriers to entry to get involved that the ordinary person can't really, and it required someone with kind of specialist skills to help get it along. So I knew that something had to change and we had to look at doing something else. So just to talk a bit more about the kit. So as I said, there's lots of different ways to measure for air pollution. This kit only measures the particulate matter levels. So it doesn't measure all the other things that the EPA have listed, and that's why it's a much cheaper kit compared to the kind of official monitoring that you get from the EPA. So what we measure is PM10 and PM25. So to kind of, for people who don't know, I'll try and explain it a bit. So the 10 and the 2.5 are referenced to the size of the particulates. So it's 10 microns and 2.5 microns. So you're looking at, to give you an idea of scale, your hair is about 70 microns. So these are much bigger. At 10 PM, they're small enough that if you breathe it in, that you can that can go into your lungs, straight into your lungs. And at 2.5, some cases it can enter your through your lungs and then into your bloodstream. So our sensor can measure these values. These typically are generated from solid fuel burning and cars and traffic. And you do get some natural sources. So if you're beside the sea, some salt can be that small. A certain time of the year, some pollen can be around the same size. But this can have a drastic impact on your lungs. Down below the screen here, we have the EU mandated levels, so you can get an idea of what's good air quality and what's very bad, will make you sick. So I think my sensor kind of mixes between good and fair, and it definitely has some spikes of poor and very poor. But we'll get on to individual sensor data now in a few minutes. So as I said, I built a sensor, this lady built a sensor, but sensors on their own aren't really enough. For this project to be really worthwhile, it has to have a kind of a network effect. So that's where Sensor.Community comes in. So the URL is there at the bottom of the page. So this is the main kind of parent project, the citizen science project that is putting together the guides on how to build the kits. They're putting together the infrastructure. They're giving people advice on how to make it. This is really the community that comes together to allow it to go from an individual just having an air quality monitoring and know where to send the data to having a whole network effect where we can have, you know, thousands of people having these sensors and getting more value from the whole and all the data than just kind of sporadic sites that you might have with kind of your EPA monitoring where you don't have the density of sensors. So let's talk about the kit itself and what's actually in it. So it's gone through a few different processes, a few different types of sensors, but it kind of stabilized around this design. So the kind of brain box of it is the microcontroller is a Node MCU. So it's an inexpensive microcontroller. It can run Arduino code for people who might be familiar with it. That's the kind of coding language designed for artists and makers to kind of lower the barrier to entry for microcontrollers. So you're abstracted away from like your C libraries and your kind of low-level coding. Other parts is the SDS011. So that's our air quality sensor. We'll talk about more of that in a minute. Another thing in the kit is we have a BME 280. So that is a temperature, humidity, and air pressure sensor. I'll go into why that data is important when we're taking our measurements. Other things that you might need when you're going to assemble your own monitoring is some cable ties to tie it all together, some plastic tubing so you can take your sample out of the air, USB cable for power, and then some sort of waterproof box to put it in. From the earlier photos, you can see my first one, I used some kind of standard WAV and piping to put it in. It was easy to go down the hardware, just to get two elbow joints, put them together, and have a waterproof case. Later on, I'd look at using more kind of sophisticated waterproof casing that were a bit cheaper and easier to work with. So this is the sensor itself. This is a dusty photo I took last night of one just on my shelf. It's mainly measuring 2.5 PM, as we talked about before. It's a relatively low cost air quality sensor. If you kind of read the background and the specification sheet, they kind of, you can get a lot of other sensors that are smaller. They went for the, we'll keep it a little bit bigger, but improve the accuracy and quality of the sensor and don't kind of sacrifice that for the sake of space. So it uses laser scattering. So what it does is it sucks in a sample of air. It fires a laser through it. That laser then hits a diode behind it. And the amount of particles, the amount of light that's blocked when it goes through it, we're able to determine the quantity of the amounts of 2.5 and 10 PM particles in the air. What this sensor can't do is it can't tell us if these are pollen or pollution. At the price points of just around €25 for this sensor, there's no way you're going to be able to tell what the particle is made of. We can just tell how many of that particle size exist. And we'll use that to kind of indicate the levels of pollution. So that kind of gives you an idea of the difference between an EPA site and one of these sites with the low cost. All in all, the kit would cost you about €50 ordering it from EU suppliers. If you're willing to wait a bit longer and order direct from China, you're talking, you drop around to the kind of €30 mark. So the sensor has a lifespan of about 8,000 hours, which the amount of times the program samples, you're looking at about kind of 5 years estimated lifespan. So the coding. So when I originally kind of started working on the project, the kind of global project and helping out was back in March 2019. You had to download the source code yourself. You can install a cross compiler, all these kind of complicated things. What is great the community has done is they put enough engineering into it to require that an engineer isn't required to load the software. So you don't have to download the code. It's available on GitHub if you want to have a look at it, but there's no need to download the actual code anymore. You download this small little program. It's cross-platform. You run on Windows, Linux, Mac, whatever. You plug in your board over USB. You pick the language that you want. You hit upload, and it's all it's all done for you. There's no need to look at the code. It really removes the barrier to entry. There's no engineer or software developer needed. You plug it in, you hit the button, and the code goes on it, and you have a working sensor ready to go. So let's talk a bit about the data itself. So the data is uploaded to Sensor.Community. But what's good about kind of the direction that this community has taken is they've decided that they're not creating a silo of like, we're going to be the place that will store your data and nowhere else. They've built in features into the firmware that allows you to send your data to other places. So with a click of a button here on your sensor, you can send it to OpenSenseMap, which is kind of another project for storing sensor data. It's what I store my weather station data on. You can send it to this Russian project called AirCMS. You can send the data to lots of different places. You can send it to a local server, say like running a Raspberry Pi, and then you have like InfluxDB or something locally to graph your own local data. It really allows you to send your data everywhere and not have it siloed off. And then these other apps and other third-party services can then get use of the fact that there's 10,000 sensors and really gain a benefit to other people and society at large who mightn't have their own sensor. And another thing to note is that they've decided to not store any data locally. So if you don't have Wi-Fi or connected to the internet, then you miss a measurement. So there's no concerns about storing data, about increasing the cost of the components to have kind of local storage. Everything is stateless. When you have the data, you send it. If you don't have internet, well, then you miss the data. But that's okay when you have this kind of networked effect and loads of sensors available around the place. So I want to briefly talk about evaluation. I've mentioned comparing this sensor to one from the EPA. I guess the big difference here is this sensor it's not factory calibrated. You will not get a nice calibration certificate when you buy the unit. It's just too cheap to be at that level. So the project has worked with lots of researchers. If you go to the URL below, there's a couple of different academic studies that evaluate the sensors and different types of sensors and their accuracy. So I'm going to attempt to paraphrase some of the results. And what they found is the particular sensor that they're using. There's a great level of consistency between the sensors. So that means if you have sensor A and sensor B beside each other, they'll give you very similar readings. Some of the downsides of the sensor is it doesn't work well when there is lots of fog. So that's one of the reasons why there's a temperature and humidity sensor deployed with them. So we know that, okay, if there's fog, then maybe the sensor data isn't accurate at that time. Another thing that the research found was this unit can get weird spikes over short periods of time. So one of the things the project suggests is don't look at, say, like minute by minute values of your sensor. Look at your hourly and daily mean to get an idea of what's going on in your community, rather than kind of minute by minute accuracy. So again, going back to my story. So as I said, started on Twitter. I built one. Then I helped that lady build one. Then, as with most Irish traditions, something starts in a pub. Where I was at a tech meetup, and I was telling the person about this new unit I had put up my house, outside my house, and showing the data. And it turned out that that person's partner was a Dublin City Council Green Party councillor. So they were going, oh, my partner might be interested in that. And after a few back and forth emails and chats with them, I decided to put on a workshop for 5 people. We had lots of Green Party councillors in. You can see there the lady is hammering out the case. At that stage, I'd moved from using pipes to using these kind of electrical junction boxes as a better fit and kind of more aesthetically better looking for outside the house. So I put on that workshop for 5 people. We built 10 sensors. But one of the issues I found with the workshop was there was a lot of aftercare. So it's probably a combination of not giving enough information in the workshop. The documentation still wasn't great. This was the middle of 2019. The documentation still wasn't very strong. And I could see some issues where, so these people went away with their 10 sensors, but to help them, I was answering constant emails. There was a lot of aftercare support, and just, it wasn't scalable. Like if I had ran more workshops, I'd be answering even more emails. So it just wasn't sustainable at that sort of interaction. So let's jump ahead a bit to Christmas last year, so Christmas 2019. I was going to the CCC conference in Leipzig in Germany just after Christmas. Massive conference, like crazy numbers, like 30,000 people go to it. They have a whole conference area called the hardware hacking area. And I decided, hey, I'll put on a workshop. The people that go to the conference are more technical inclines, so maybe it'll be easier to run the workshop. So I brought 20 kits with me over to Germany. I started doing the workshop, and 2 minutes into the workshop, I get a tap on my shoulder, and they go, hello, we're from Sensor.Community. We're the people who founded the project. It's great to see people doing workshops. So it was a great experience to meet the founders of this particular project. They're all from Stuttgart originally. It was great to get their insights, their learnings. I was able to bounce ideas of the trouble I was having in Dublin and creating and kind of getting better growth and more sensors out there. I was answering emails. I gave them feedback on their documentation and tried to kind of figure out a way to how to get more sensors out there. I myself, I couldn't run enough workshops because there was just so much kind of aftercare that kind of went with it. So based on their advice, I decided, okay, I'll give it a go again. So that was Christmas. So I knew Engineers Week was coming up March 2020. And I said, all right, I'll give it a go for Engineers Week. So I decided to do 2 workshops. This time I jumped from 5 people up to 20 people at a time. I took on a lot of the advice from the guys in Germany. So what difference with this workshop is, the original workshop I was doing was an hour. I put this out to 3 hours long. Instead of having tools for every single person at the workshop, I made it a point to only have 1 set of tools amongst 3 people. Same with the documentation. I didn't print out instructions for everybody. I only printed out 1 for every third person. I didn't go through it like standing at the top of the room like a teacher and go through every step. What I did was I created the environment for conversation, for peer learning to happen. People came down, we sat, we talked about why air pollution was hampering their lifestyle, why they were interested in it. People got to know each other around the table. You know, the workshop took, as I said, 3 hours, but people got to know each other a lot more. We had lots of peer learning going on. We had people checking each other's wiring, so there was less faults, less broken equipment, less fried sensors. People, because it was a bigger atmosphere and, you know, they weren't asking questions to the teacher like in previous workshops I was doing, they were asking like their peers. People learned a lot more. The workshop ran a lot smoother. You wouldn't think jumping from 10 to 20 people, you think it would be a lot more work, but people helped each other. People kind of co-learned. And then afterwards, they continued to help each other. So when they went to installing their sensors outside their houses, they all helped each other over email. It really made the scalability of the projects much easier. The community helped themselves. There was no longer a bottleneck of me answering just emails. Everybody was involved. They all helped each other. And I found that over the next few weeks, lots of sensors popping up on the map around Dublin. Some people traveled from Belfast, so we had some more in Northern Ireland. And it really created more of a buzz. Even then on social media, people were talking about all their sensors that they had built up. And then more people, you know, got involved and more people then built their own sensors. So I felt that kind of community approach, the recommendations from the guys in Germany really helped with the growth of the network. And it really was a better way to build it out. And then unfortunately, COVID hit, so I haven't had the opportunity to run any kind of more workshops with these kind of larger scales or hold events to try and encourage another round of people to make it. I guess it really allowed these people to create a sense of ownership of their sensor. So let's have a quick look at the sensor network itself. Just reading the data from last night, there are just over 11,500 sensors active around the world. The project started in Germany, so you might understand why Central Europe there has a much higher density of sensors than anywhere else. The project originally was only available, the instructions in the German language, so you can see why it kind of grew a lot in Germany first, but now it's spreading out to much kind of further afield. Let's jump and have a look in Ireland. So there was no sensor on the map the day I turned on mine, and we can see how much it's growing more and more. So I looked at the data and there was 42 sensors online last night reporting data. So it's great to see such a density of data. Just zooming a bit here into Dublin, we can see that we have great coverage. Like, you couldn't, it wouldn't be financially viable for the EPA at their cost of units to put this amount of sensors in Dublin or around the country. It just wouldn't make economical sense to put this amount. But because these people have a sense of ownership of their sensor, and they're their sensor and they feel a part of the community, we can scale this up a lot more. And I hope that out of this talk, people be encouraged to have a look at the website, understand that it's very easy to get involved and build your own sensor and put it up in your house. So it was doing got lots of media coverage going around, and there was big questions. So we went into lockdown. There was no cars in the street. You must have noticed a drop in pollutants and air quality increase. It must have been great. Well, I didn't see any of that. So a week before lockdown, I'd been saving for a while, and we finally pulled the trigger on getting some external insulation put on my very old house to improve and get a better BER rating. So the scaffolding went up the week before lockdown. I'd taken down my sensor. The builder promised, oh, we'll be done in 2 weeks, no problem. We'll put all your fittings and your sensor back up on the wall. We hit lockdown. My sensor was offline for weeks and weeks until the end of lockdown, and the builder could come back and take down all the scaffolding. And then I missed that whole window of capturing data to see if we saw a drop in pollutants during lockdown and when there was a huge traffic decrease. But fear not, the EPA are great. So at their conference, they recently released a paper, and they engaged with lots of academics to do a study on the impacts, the environmental impacts of the lockdown, and see how it improved. Can we learn anything from it? The link for the full paper is down there on the bottom. These are the key observations that I copied just from the air quality section. They go into lots of other sections about the environment. So the key points they measured in, yes, we saw a lot of the different levels drop, but the PM levels still stayed quite high. So we have to remember PM tends to come from two sources. One is traffic, but the other one is solid fuel burning. And during the start of lockdown, we're still into the home heating season, I guess. So we still had people with their burning solid fuel, their open fires, their gas boilers. So we didn't really see a drop in the PM levels. But in some of the other values that the EPA measure, you did see a drop in it. So I guess it's to understand that, yes, we get pollution from road traffic. If you have a sensor directly over the M50 or a very busy intersection, you will see a drop. But the ones in the general environment that aren't above a very busy road, we didn't see a huge drop. But yeah, read the report. It's very interesting, and there's some good findings from it. But so let's talk a bit about my sensor and my experience and running it. So this is the data from almost a year, just over almost a year ago now, 30th of October 2019. So the green is PM10 and the cyan is 2.5. And so I live in an area which is predominantly ex-Dublin City Council housing. So they were all built around just over 60 years ago. So a lot of them still have open fires. So we'll see what's typical in the winter months. You see the increase start around 5 o'clock, start to get much higher about 7:30, 8 o'clock, where you have everybody lighting their fires, heating their homes, typical sort of use case that you'd see on a typical winter's evening. But what's interesting is, so this is the 30th, what a difference a day makes. So let's jump to the 31st. And no points for guessing what's special about the 31st of October and what's going to be special about this Saturday. It's Halloween. So have a look. So I'm going to flick back and forth between the two again. So this is the day before Halloween. Well, we have a peak with just under 30 there. And let's have a look at Halloween. So we can see a massive increase in the pollutants in the air. the amount of bonfires burning locally, the amount of fireworks being set off. We can see an initial spike at about 5:30, which is the first wave of kind of earlier kids. And then you see when the adults and the bigger bonfires start being lit at about 7:30, 8 o'clock, and the values go through the roof. So yeah, it's one thing to be mindful of this Saturday if you're going out and around the place. That yeah, the air quality will probably be particularly bad if there's a lot of bonfires, if there's a lot of fireworks going off, and maybe people with asthma or particularly sensitive to air pollution, they might want to think about staying in. So this talk is all about the community. I've talked a bit about the lessons about the community aspects in workshops. Some of the other tools that the community use is they have the concept of labs. So that's where local groups can get together, put themselves on the map like we have here on the left-hand image, where they'll hold weekly and monthly meetups where people come along, where they can build a sensor, or they can discuss pollution, that sort of aspect, and all their concepts around air quality. They also have their GitHub page, obviously, where they get software developers and engineers to contribute data, like adding on different sensors, adding support for sending your data to other places, bug fix. They also have online chat where people can discuss issues, post questions, that sort of thing. So all of these are kind of mechanisms that the Sensor.Community uses to encourage the kind of community leaders and people at large to set up their local communities and try and keep the project going and building. So as I said before, it's an open project. It's all about community focused. And here's one example of, because it's an open project, you can start playing with it. So this is a sensor I built about September last year. So in our local makerspace, we have a woodworking shop. People are often cutting plywood or different type of woods. You get a lot of sawdust and stuff in the air. And the idea was to build something to give people a visual reminder that please wear your respirator. Please use the shop vac to suck out all the sawdust. And trying to keep people, to help them make better choices and keep themselves, their lungs a bit clear. So this is a 3D printed case that someone designed. So they put up their STL file, excuse me, to allow anyone like myself to download. Someone made a contribution and added code to support a screen. So all this works out of the box in the firmware. It was just connecting the wires. It's very similar to the sensor I have outside. The only difference is the addition of the screen, and allowed me to put this up in our woodworking shop and to have people have then a visual representation. Oh, yeah, there is a lot of sawdust in the air. My sensor is telling me I should open the window and put on a respirator, and so on. So where is the project going? Sensor.Community has matured extremely a lot. The guides have got so much better. It's easier to find the parts, but they want to keep going and have plans for the future. So in beta at the moment is they have a noise sensor. So you can see, you can measure the level of ambient noise. So we can see if particular roads are very noisy, if a construction site is very noisy. So this project is in beta at the moment. You have to get your own circuit board printed. It's a lot more involved in making it, but they hope to refine it more and more, that it will be in the future become as easy as the air quality one, where it doesn't require an engineer or soldering or other complexities to get it up and running. Another thing they're looking at is adding LoRaWAN support. So LoRaWAN is a low-powered network system where you don't have to use Wi-Fi. It has distance in urban environments over about 1 kilometer. In the countryside, you can get 3 to 5 kilometers depending on the antenna, but allows you the fact to make these air quality sensors mobile, which means you can put a GPS on it and say, put the sensor on your bike for your commute to work. Use LoRaWAN to upload your data and have the data mapped on your path to work, and allow and allow us to get better data that allows us to put these sensors in places where we mightn't have Wi-Fi, or we mightn't have much power, where we have to run it off solar. Lower WAN will allow us to run it at a lot more lower power requirements. And the other thing is, they're looking at measuring, moving on from just measuring PM values to measuring nitrogen oxide using diffusion tubes and other ways to add to more of the different values that we talked at the very start about the different elements that impacts air quality. So just to surmise it up, I guess all this wouldn't have been possible without all the work that originally started in Stuttgart by the Sensor community. They're the people who built the project originally. They're the people who allowed myself to take part and then try and build a local community here in Ireland, where we have 40-ish sensors uploading data. Without them, without people all over the world contributing, it would just be me in my house with one sensor, and we wouldn't have that great network effect, and then kind of build on and have that really community-driven kind of low cost network that allows so much more people to take part. We've removed the barriers to entry. We're democratizing this technology to allowing it to be used by everybody, and not just by engineers or computer scientists or people who like to tinker and that sort of stuff. We can have the average person have one outside their home and be contributing to a better understanding of the local environment, where pollution comes from, and contribute to a scientific endeavor. So thanks very much for listening. If you'd like to get in touch with me after the talk, my Twitter handle there is at the bottom, Jeffrey_Roe. And thanks again to Electrical and Electronic Division and the Young Engineers Society. We're going to open it now for any questions that might be in the Q&A.
Thanks, Jeff. That was an excellent presentation, I have to say. Really picked up a lot there. I'm Brian Feehan. I'm the chair of the Young Engineers Society, so I'm going to manage this Q&A for Jeff. So if people have questions, I suppose, please use the Q&A function, and I'll keep track of them. So I suppose I'll kick it off. Jeff, I suppose I'm on site in Dublin Port at the moment. So again, I think the EPA have quite an extensive or comprehensive suite of sensors down there. In terms of site, I suppose it could be interesting. You mentioned that there's a small discrepancy. I wonder whether you could use these, I suppose, to keep track of dust levels, and I suppose that from a monitoring perspective around the site, whether, you know, again, you could this WAN technology might enable some low-level monitoring of sites, whether you think that's possible.
Yeah, I think in those sorts of environments where you got a construction site, you're not guaranteed to have Wi-Fi coverage everywhere. Definitely lower WAN is the technology to use. So we have in Dublin, we have the Things network. So it's an open lower WAN gateway. We have Smart Dublin, the government initiative from the four local councils in Dublin. They're kind of smart city. They have rolled out some great lower WAN networks. We have the smart docklands. We have a system rolled out there. So there are networks out there for people to use. Definitely, if this technology can be used, if that isn't available, there's definitely commercial support. So you could use a technology called Sigfox, which is kind of like a commercialized version of lower WAN if you didn't want to kind of roll your own network.
Very good. Thanks, Jeff. So there's a couple of questions in here. I've one from Dara Rogan, who's asking, what do you think about platforms like Smart Citizen or Purple Air or WAQI, AQICN with their kit?
So it's a very big topic at the moment. I'm concerned about platforms they'll commercially sell you the sensor. I'm concerned about data portability. So I, for example, have a smart sensor in my greenhouse, and I have one in my hallway monitoring humidity and temperature. So it's from a company called Minute. And yeah, I can look at the data fine, but yeah, I can't export it anywhere. I can't graph it anywhere. So I'm very concerned about the commercial players creating silos for their data. And I'm sure it's in their business model to sell that data on a whole to interested parties like the EPA or anyone else who's interested. But kind of the open source platform approach like this, they're not creating a silo. They'll allow you to send the data anywhere. They want people to use it. We won't want to lock it behind a paywall or that sort of thing. So yeah, I haven't looked into all the examples the person has mentioned because yeah, those commercial units cost money, I guess. So I haven't bought them, so I couldn't comment on the actual those ones. But yeah, if you're buying one of them, check what you can do with the data, who has access to the data, and yeah, can you download a free Android app and have it on your phone or have it remixed in a way that you like it. With these kind of community approaches, you can, and that's what makes them great.
Thanks, Jeff. I have a couple of questions from Edward Malarkey here. He's, I suppose it's around the construction of the sensor. He's asking about the positioning, whether the data might be affected by the likes of it being near your wall vent, as well as whether there's some sort of a fan required to circulate the air for it to be monitored.
Yeah, so the manufacturer, if you read the data sheet of the chip, they have some suggestions, stuff like the unit should be only horizontally, because the way it works. Being placed next to my fan, that fan there, I have an old house, that fan has been long blocked up before people thought about having vents in each room and having properly ventilated rooms. So I didn't really have much impact for that fan there. But yeah, placement will have a big impact on it. On the website, when you're commissioning your sensor, they use a scale to indicate, okay, is your sensor going to be on the front of your house? You indicate how high you're placing the sensor. They recommend at least above 1.5 meters, ideally 3 meters if possible. There's loads of these recommendations that I didn't really go into on the in this talk, but are listed on the website to kind of give you a help to how to place the sensor. Other thing about the fan, about air circulation. So the fan, so the sensor does have an inbuilt fan. So when you power it in, you can hear it spinning every now and again to take its sensor. If you look at the kind of boxes that I ended up using, so I built one myself first, and I thought, oh, I better not let any water or humidity ingress into this. So I sealed up the box as much as possible. It worked fine for about a day, and then I was getting crazy results out of the box. And it turned out that it was taking a sample, and the sample was then going into my waterproof box. And because I had it sealed so much, it had nowhere to go. So I definitely learned a lot of lessons about having open air and allowing the sample to move away. So that's why on a lot of them, I've extended the intake tube a lot further away from the box. So it allows us to try and take a fresh sample of air and not just read the same sample that you happened to take before.
Thanks, Jeff. I have a question here from Paul Dillon. What is the reliability of the devices with regard to the microcomputers involved? How do they compare to commercial devices?
So I don't have it to hand here, but the project hopes that they will last 5 years. So that was when they released them in Germany. I found, so the original model had a different type of temperature sensor, and the Irish humidity just kills them. I was getting like 6 months out of the original sensor. So that's why they moved to the BME sensor is a lot more forgiving to high humidity environments. So since we moved to that sensor, since I added more ventilation to the box, I've been running mine, the newer version now, for about a year. Some people have been running it a bit longer. There seems to be no problems with that. I did encounter some problems. It seems it's a curse of modern day that it always comes down to software, that they pushed an over-the-air update. I had the sensor ticked for beta updates, and so it took a beta version of the firmware that had just been released, and of course bricked the whole thing and required me to get up on a ladder. It was when I had put the sensor up much higher, up on a ladder to take it out and flash a new firmware, holding precariously a laptop and a USB cable. So getting back to it, I guess the new sensor is much more reliable. If you stay on the stable channel of the firmware, the reliability is much better in the unit. I've never bought a commercial unit. I haven't had the money to buy a commercial unit. I've had some chats with the Dublin-based company that build a lot of the units for the EPA units, and I've looked at some of the tender documents, and they require a 3-year lifespan for some of their kind of public procurements of these type of sensors. So that's the kind of lifespan that the government are requiring for their tenders.
Thanks, Jeff. A couple of questions here, I suppose, around the data itself, I suppose. One is again from Dara, asking about, in terms of privacy concerns relating to people sharing their location. Is there a way to anonymize the location somewhat but still contribute?
Yeah, so in your user profile, you can select how detailed of an address you give for the sensor. So I think the default is 50 meters. So it'll draw a hexagon around where you give it an approximate location, and it draws a hexagon around, and it'll only allow you to zoom in to 50 meters worth. When I'm telling people when they're putting their sensors, I usually tell them, put it in the middle of your street. You know, people will, it'll be anonymized to the middle of your street, and usually people will then find it could be any number of houses on a street. Of course, it's a lot different when I put one in my parents' house, who live in the middle of the countryside, and you can definitely tell whose building it's on, because there's no one else, there's no other houses around for miles. So yeah, so it usually pulls it out to about 50 meters. You can not include your location as well, but I'm not sure how much usability of the data when there's no location attached to it.
Great. A second, or I suppose the second question on the data here is around, I suppose, could you expand on how the data is being used more generally by the likes of universities? That's from Porrick O'Dwyer.
So I read a study about it being used in the Netherlands, and what they have found is the raw data on its own, unfortunately, is pretty useless. So the data from your sensor, what you need to do because with air quality is combine it with weather data. The wind speed, whether it has rained or not, has a huge impact with the particles in the air. So they've done a great study where it allows you to look at the air quality data, and it automatically pulls in the weather data and gives you a better combined result. It looks at applying a scaling factor based on the humidity levels that comes from the humidity sensor. And they've done a lot better work looking at the data, and they've produced it now. So you can look at it in the particulate app. I think the defined value where you're not getting the raw value. So they use a lot more in combining those data together, because local weather has such an impact on, because when it's windy or when it rains, will have an impact on the values a lot.
Thanks, Jeff. I've one last question that's just come in here from, I think it's Fernandez, I hope I'm pronouncing that correctly, apologies, around who we can contact for technical support in the middle of making his own sensor or her own sensor.
Yeah, you can definitely contact me on Twitter, Jeffrey_Roe. You can definitely give me a contact. I built a lot of sensors, done a lot of workshops at this stage. I'm halfway through building the noise sensor. I got some PCBs done up and I have to cast it in the acoustic resin. So I'm in the process of building one of them. So yeah, you can definitely contact me via Twitter, and yeah, I'll be able to help you as much as I can, and maybe suggest someone locally to you if you need help with the installation part.
Brilliant. Well, that's us for questions. Thanks again, Jeff. It's been a really informative evening, and again, thanks to the Electrical and Electronic Society for hosting this event. Definitely check out both the Young Engineers and the Electrical and Electronic Society on their social media channels. Thanks.